Avogadro's law helps us to look at changes in volume and the number of moles while the temperature and the pressure are constant. Avogadro's laws also tend to be used together along with problems that have to deal with STP, standard temperature and pressure. This question here does not necessarily look at changes in the volume and the number of moles, but we're using Avogadro's law and STP concepts together. So let's see what we're given. We're given 100 grams of oxygen is added to 40 liters of nitrogen gas. What is the total number of moles of the combined gases at STP? So we want to know the total number of moles. So what is that? The number of moles of oxygen plus nitrogen gases. Okay? And it's asking us at STP. Well, STP, we know that the volume of 1 mole, STP 1 mole, has a volume of 22.4 liters. Okay? So if I have 1 mole of a substance or of a gas, it's going to have a volume of 22.4 liters. So we're going to use all this information together to solve this problem. So what is the total number of moles? All right, we're given grams and we're given liters. So if we go back a little while ago, you remember that in order for us to go from grams to moles, we need the molar mass. And we want to go from liters to moles, then we'll use the information from STP, where our 1 mole is equal to 22.4 liters. Okay? All right, so how many moles of gas, of oxygen, do I have? How many moles of oxygen gas? Well, if I start with 100 grams, and remember the molar mass of oxygen, you have to take from your periodic table. Each oxygen atom has a mass of, or if we're looking at each mole of oxygen atoms, is 16. So for a mole of oxygen gas, we've got 1 mole is equal to 32 grams of oxygen. Put that in our calculator and we get 0.31 moles of oxygen. Okay, so that's molar mass stuff. But what happened to Avogadro's? Well, remember we have to use our STP information. And Avogadro's law just simply says that if my volume increases, then it must be because the number of moles that I had increased, right? So, the number of moles of nitrogen gas now, because we're given a volume and we're at STP, then we know that 1 mole is going to be equal to 22.4 liters. So if I have 40 liters of nitrogen, 40 liters of nitrogen, and if I'm at STP, that means I've got 22.4 liters per 1 mole of nitrogen. Right? So that's going to give me 1.79 moles of nitrogen gas. Well, the question is asking for a total number of moles. If we add those two numbers together, we get 2.1 moles of gas. 2.1 moles. Now, what about our number of sig figs? Well, we started off with 1 sig fig here, 1 sig fig there, so that means that we've got 2 moles of gas in total.